Hello everyone, and a very warm welcome to today's event. My name is Anne-Marije Zwerver, and I'll be your host of today. And on behalf of QuTech, Quantum Delta NL, KPN and Cisco, it's my pleasure to welcome you at this live program, this live event, a program that will feature a demonstration of the next generation of quantum communication and cryptography. It will feature a demonstration of measurement device-independent quantum key distribution. Quantum communication and cryptography is a field that poises to revolutionize many fields as we know it today. You can think of secure communications with online banking or secure governmental communications and much, much more. On the following slide, you will see the program and what to expect of the coming hour. Here you see it. We will start with a panel discussion on what the demonstration actually entails. So how did the demonstration come about? And what does it mean for the Netherlands and for Europe? Of course, we go into more detail for the demonstration. Thereafter, we'll have the actual demonstration, followed by some messages from special people. And then we will end with a live Q&A, where you can ask all the questions you have, and you have the opportunity to do so. If you want to ask a question, just hover your mouse over your screen, then a text box will appear, and you can ask your question there. And we'll try to answer as much questions as possible at the end. Throughout our program, many distinguished guests and also colleagues who contributed to this demonstration will be featured here today, both online and in the studio. And with us in the studio are Dr. Joshua Slater, Team Lead Quantum Communications at QuTech, Jesse Robbers, Director of Quantum Delta NL, and Dr. Victoria Lipinska, Quantum Advisor at KPN. So thank you all so much for being here, and a very warm welcome to you as well. Josh, Jesse, and Victoria, would you provide us with some introductory words, starting with Josh?
Yep, sure. My name's Joshua Slater. I'm a quantum scientist, quantum engineer by training, and at QuTech, I'm a team lead on one of the quantum communication teams, more on the applied sciences, working towards interacting more with industry, getting stuff out of the lab into the field. And it's my team, all of us, that are responsible for what we're going to see today.
Yeah, exciting. Thank you.
It is.
Yes, sir.
Yeah, so I'm the director of Quantum Delta NL. Quantum Delta NL is sort of an umbrella organization to speed up the technical developments on quantum technology in the Netherlands, with programs around supporting developments of quantum computing, quantum networking, and quantum sensing, and supported that by action lines about long-term research, building up the ecosystem, building educational programs on academic level, HBO and MBO levels in the Netherlands, and having an ethical discussion about the impact of quantum technology on society.
Very broad, very important. Welcome. Victoria.
Good afternoon, everybody. My name is Victoria Lipinska. I'm a quantum advisor at KPN. KPN is a Dutch telecom provider, and my role at KPN is to take care of all the quantum end of all the quantum-related efforts. And my background is in quantum communication and cryptography.
Thank you. So later during this event, Kees Eijkel, Director of Business Development at QuTech, will also join the table. So we'll see him shortly. And who's not with us today, but who will see online, online, and we'll see online right now, is Professor Stephanie Wehner, Roadmap Leader of Quantum Internet and Network Computing Division at QuTech. And she has a welcome message to you all that we'll see now.
It's a great pleasure to meet you online virtually. My name is Stephanie Wehner. I'm here as the Director of the Quantum Internet Division at QuTech. And it's a great pleasure to introduce to you Joshua Slater and his fantastic MDI-QKD system in this demonstration. MDI-QKD is very suited to enable secure communication between many users in the metropolitan area. And in this demonstration, we also show that this can be done next to standard telecom equipment, meaning on fiber that is already used for other purposes. MDI-QKD also forms an important step to preparing a quantum internet of the future, since it creates infrastructure that can later be upgraded to a full quantum internet system. So without further ado, I hope you enjoy the demonstration today.
Well, let's start and let's dive straight in. Jesse, why is this step in quantum communication and quantum cryptography so important for the Netherlands and for the rest of Europe?
If you look into cloud computing, if you look into quantum computing, that's the fundament of cloud computing and hyperscalers that we're using more and more today. If it comes to quantum networking, this is the future fundament of the digital infrastructure that we run today. So if you look into the developments that are going on, this development is a great step to form that future digital infrastructure that we have on national level, but also on international level.
I see. Thank you. Before we go to the actual demonstration, Josh, can you give us some background on how this project came about and how much time went into preparations?
Yeah, with pleasure. So research, academic research into QKD and MDI-QKD has been going on with research at QuTech for some years, like in the group of Professor Wolfgang Tittel. But about a year and a half ago, we started having the discussion, should we involve more engineers? Should we make the transition to make something more connected with industry? And that's where my team kind of stepped in. I mean, QuTech made the decision and we started rolling with it. That was early 2020. Then unfortunately, COVID hit. So we had about 4 months of home office, 6 months of basically working from home 50% of the time. But it was actually kind of a blessing because that allowed us to really take apart the science, go back to the basics, redesign the optics and the control plane, for instance, redesign a lot of the system to work really in the field, make it reliable, make it stable, make it work alongside the conventional networking equipment that was provided by Cisco. We wanted to do that because we wanted to make sure that we could literally put the system on a truck, ship it somewhere, and have it turn back on, right? Without having things like PhD students standing beside it, needing to babysit the thing.
Sure.
Yeah, so it's been, it was a good year of work once we got back to the office, but we're very excited with what came out of that.
Very nice. And I heard that you started with all the equipment in one node, and then you distributed the equipment over the other nodes, which is the main node is Delft, and then you distributed it to Rijswijk and The Hague. And I think you have a movie about that, so let's have a look.
This is actually the last time the system is all running in the same lab. Alice will be staying here, Charlie will be moving to Rijswijk, and Bob will be moving to The Hague.
Yeah, I really like that video because it shows all the members of the team that can't be with us today, like Thomas and Raymond, who we'll see later, Kenneth, Professor David Alkos, Bruno, another Raymond. There's unfortunately one member of the team. He passed away just before we started filming, Andre Reis, but he contributed a lot to the demo as well, of course. But it's important for me to make it clear that it's a team effort, and there's so many people that were involved in making this happen that aren't here in the studio.
Yeah.
Yeah.
It's an amazing team effort. Thank you. I also think it's very impressive logistic, actually. And Victoria, KPN provided some of the logistics and also played a very important role in this work. What has KPN's role been exactly, and why did KPN decide to partner?
Yeah, it's an excellent question. Thank you for that. Security has always been a very important topic at KPN, and in very specialized applications that need very, very strong kinds of security, it's important to look for solutions that are as future-proof as possible. Now, MDI-QKD is one of those solutions, and we're very happy to see and to be a part of this effort. The motivation to look for solutions like this already right now is that we know that computers are becoming faster and faster, and those, not only quantum computers, but also regular computers, might pose a threat to the security as we know it today, to current crypto systems. Therefore, being a part of MDI-QKD is a very exciting endeavor already right now.
I understand. It's nice to see so many partners coming together, actually. Josh, can you give some technological information on the system, as in how did you build it, what were the challenges? Basically, can you walk us through the system?
Yeah, sure. So it's a QKD system in the end. So the idea is that the two end nodes, which are in Delft and in The Hague, they're going to generate cryptographic keys. They're basically bit strings that are identical at the two places. And they're going to do this in such a way that anyone trying to tap the line in between could be detected by the system itself. So there's a lot of hardware that goes into it. The two systems, they generate quantum signals, and they send these quantum signals towards the center node. This is in Rijswijk. And there in Rijswijk, there's a particular quantum measurement that's happening there. It's called a Bell state measurement. Questions for later, I'm sure. And it's because of the nature of this quantum measurement, careful work has to be done to ensure the stability of the fiber in between, the environment in between. And the system handles this entirely by itself. So it monitors the length of the fiber as it changes, it monitors lasers, and it monitors temperatures and things like this. There's a lot of control systems that go behind this. But in the end, when it generates this key, I mean, what happens is this just gets pushed off into key servers. So this is just software then that's running at these locations, and any other application can really make requests to this key server and say, I want some key, can I have some?
I see, very interesting. We actually made a an animation on this measurement device independent quantum key distribution, and I think it's time to have a look at this animation right now.
MDI-QKD is part of the next generation in quantum communication and quantum cryptography, a field that promises to make our global communications more secure. Our MDI-QKD network will drive our global communication towards a more scalable quantum internet. We want to provide secure communication between data centers, banks, airports, and between governments, now and in the future. Our MDI-QKD network operates with a central node that acts like an old-fashioned telephone switchboard, connecting users like Alice and Bob. Alice and Bob send qubits to the central node, where they are detected. They can use information about this detection to establish a secret key, bit by bit. That key is used to encrypt and send data using conventional encryption methods. Due to the quantum nature of qubits, any eavesdropping or manipulation can be detected by Alice and Bob, allowing them to know if their connection is secure. It's possible to connect many users via a single central node that allows each user to generate a quantum key with any other user. This makes our MDI-QKD network practical and scalable. The central node can also function as part of a quantum signal repeater, facilitating quantum connectivity between different metropolitan networks. And most importantly, Alice and Bob's secret data is never available at or known to the central node. Therefore, neither hacker nor central node can learn any of Alice and Bob's secrets. This level of cybersecurity will be the cornerstone of our future quantum network.
A very promising network, or a very promising demonstration indeed. Today, we'll actually do it with 2 nodes. And before we continue and watch this demonstration and of this next generation quantum cryptography system, Josh, would you like to introduce the team?
Yeah, with pleasure. So our center node is sitting in Rijswijk, a lovely city in South Holland, and our colleague Ingrid Romein is there. She's a program manager at QuTech. Over in The Hague, this is a KPN building. We've put one of the end nodes there. It actually looks very similar to this in the end. This end node we call Bob, and running that at the moment is one of our colleagues, Raymond Berovitz. He's an optical engineer at QuTech, and he's one of the 2 optical engineers that spent really the most time hands-on with the system, building it and such. The other one is Thomas Middelberg, and he's running the system back home in Delft at QuTech right now, the other end node.
I see.
And I believe they are very excited to show, especially Thomas is excited to show what Alice looks like.
That's right, Josh. Here we are at one of our end nodes. And this rack contains the equipment that we have built ourselves. It contains the optical and electrical components that generate the qubits. This is Alice, and she is connected to the rest of the network of KPN by these fibers. So my name is Thomas Middelberg, and I'm an optics engineer here at QuTech. It's been fantastic to work here. So the last year and a half has been a roller coaster. It's been a lot of challenges, and I've learned a lot of things, and I've had a lot of fun. Connected to Alice are also our control laptop and the network controller node. Over in this side, we have the computer of a typical user who can use the key that we generate for various applications. Our other end node is over in The Hague. That's where my colleague Raymond is right now.
Yes, that's right, Thomas.
Yes, indeed. And right here we have the other rack. We call it Bob, and actually Bob is going to do the exact same thing that Alice is doing. My name is Raymond Bergvoets and I'm an optical engineer at QuTech. I'm very excited to be on this project because it's such a fast growing technology and there's a lot of mystery still around it, but also a lot of development, and it's finally starting to get practically implemented, and it's really exciting to be a part of this. He's going to send qubits over these KPN fibers all the way to our central node, which is in Rijswijk. And at Rijswijk is where our colleague Ingrid is going to take off.
What we're seeing here is the center node. This is where the quantum measurement happens that connects Alice and Bob. My name is Ingrid Romein and I'm program manager at QuTech. I wanted to be part of this project because I find this whole development to enable quantum networks and ultimately quantum internet extremely exciting, and I really think this is the next big step in digital networks, in networking technology. This is the future.
So thank you, team. So we saw all the nodes right now. Victoria, 2 of the 3 nodes are at KPN locations. Can you tell us more about that?
Sure. So like Josh said just a few minutes ago, we have one node that is in Delft, that is a QuTech location, and then we have another end node that is in The Hague. And they're connected to a central node that is in Rijswijk. Both Rijswijk and The Hague are KPN locations, and in those locations we have dedicated rooms in which the QuTech equipment can actually be placed and is placed right now. The Hague location and Rijswijk Delft are connected with a fiber. And here the distances that we're talking about, if somebody's watching us who doesn't live in the Netherlands, that's about 20-25 kilometers of fiber. So this is the distance we're talking about. And what's very important to stress here is that the fiber we're using is actually a standard telecom fiber. There's nothing special about it. It can carry out regular internet traffic, but right now it's carrying out both internet traffic and MDI-QKD.
So very future-proof, actually.
Very much, yes.
Very nice. So now that we're all familiar with the system and with the nodes, but before the team will actually start the demonstration, Josh, what is going to happen? What will we see?
Yeah, so at the locations Delft and The Hague, we have a KPN application server that's running right now. It's effectively a software suite that's used for very secure document encryption and transmission. So this software suite takes in key, and then it can encrypt your sensitive documents. Right? So this is running at the 2 locations, and it's going to make a request to the key servers behind the system asking for a QKD key. The team, they're going to turn on the system really from scratch. So it should be off, and they're going to turn it on. And then once it's turned on, the system, again at a software level, starts negotiating. All the nodes start negotiating about the parameters for a QKD session, how it should run. Once that's established, once they agree upon this, the system starts setting up that quantum link and then exchanging the quantum signals. Once that kicks off, it's about 4 minutes of waiting time for the system, for the network to generate enough data about the link, enough statistics about the link, to be certain to a very high probability that there's no eavesdropper on the link. So during that 4 minutes while we're waiting, the team has made some other videos to explain some other aspects of the system, QKD and MDI and such. But then when the 4 minutes is over and the key comes back, then Thomas and Raymond will use that with the KPN application server to show some cryptography.
Share something that's encrypted and decrypted again. Mm-hmm. Very exciting. Well, let's not wait any longer, right? Let's do it. Let's watch.
All right, Raymond, are you ready to go on your end?
Yes, everything is all ready to go. I'm ready to start my servers.
Then I'll start here, the KPN application server.
Yeah, 1 sec, I will do the same. My server here is running, which means I'm going to send a request to the central node that I want to make some quantum key with Alice. And the request is sent.
Very good. Then here from Alice, I will send a request to the center node that I want to make a quantum key with Bob. Now our system produces 2 32-byte AES keys per minute on average. But we don't get these keys immediately. We need to wait for a while for the system to generate enough statistics in order to make sure that our key is secure. So now we will wait for about 4 minutes.
So, in the MDI-QKD protocol, the two parties, Alice and Bob, where Alice is in Delft and Bob is in The Hague, send their qubits to a central node in Rijswijk. Now in the central node, the magic happens. The two qubits interfere, creating different detection patterns on the detector. Now what kind of detection pattern is created really depends on the qubit state that Alice and Bob sent. When Alice and Bob send qubit states exactly opposite in value, a Bell state measurement is created, a specific type of detection pattern. Now, if the detector in Rijswijk detects such a Bell state measurement, a message is sent back to the endpoints, and then the endpoints can backtrack which qubits they had sent at the time, and they also must know what the other party must have sent, the exact opposite value, since there was a Bell state measurement.
Because of the way this system is set up, and this sensor node performing a Bell state measurement, it can also be used to connect multiple users. It's not limited to Alice and Bob only. We can add multiple Alices and more Bobs to this sensor node. And, well, in that way, create a star-shaped network.
Now, if someone tries to be clever and, for example, eavesdrop on one of the channels and listen in on what kind of qubits are being sent, something strange happens. By measuring the qubit, they actually alter the state. And by altering the state, they alter the detection pattern at the central node. This can cause Bell state measurements where there actually shouldn't be Bell state measurements, or no Bell state measurements where there should be Bell state measurements. When Alice and Bob gather enough measurements and enough statistics, they can actually see whether or not someone has tampered with their channels. And this is what makes the MDI-QKD protocol secure for generating a key.
So I view this project as really the stepping stone for the future of the quantum internet. This is the first real demonstration here in the Netherlands of an actual deployed quantum network. Different nodes that we have are actually connected to an existing network from KPN.
So the exciting thing about working together with Cisco on this project is that aside from sending the qubits from an endpoint to the central node, we are also sending two more internet signals over this exact same fiber. Now, this is all managed by routers we got from Cisco, and one of those links is the control network or the communication network we need for all the control laptops to talk with each other. The other network is also really exciting, is a high bandwidth channel of 10 gigabits per second, which is traveling again over this exact same fiber. So we have three different signals all traveling over one single fiber. And this actually shows that our QKD system can be integrated and coexist with existing networking equipment.
We can go even further towards the next steps of a quantum network, a quantum internet, and instead of having Alice and Bob sending single photons over the network, we can use it ultimately to connect quantum processors on one end to quantum processors at the other end and create entanglements between those.
We are making these key servers that are basically ready to grab key from the QKD system and pass them to whatever application wants to use them. So if anyone would be interested to use our key service, it would be as simple as getting the key and using it for whatever application they want to use it for.
All right, any moment now. Oh, perfect.
Yes. We have quantum key.
Okay, so now we have actually successfully extracted the quantum key from our quantum servers onto the KPN server. And now we can do interesting stuff with it. So the thing I'm going to do now is I'm using this key to encrypt an image and send it to Thomas over email.
I've just started the KPN application server, which is one example of an application that can use the key that we generate.
Now the image, unencrypted, looks something like this. Now, everyone can make sense of this. It's the logo of Quantum Delta. But if I now encrypt this image with our secret quantum key, the logo starts to look like this. Completely unrecognizable. And now I've sent the message and it's waiting for Thomas to decrypt it.
So I've just gotten an email from my colleague Raymond with a secret message that has been encrypted with the quantum key that we just generated. And if I open it up, you can see that it's in its encrypted form. There is no way to tell what this image actually looks like. It's all been scrambled. So now, using my copy of the quantum key, I can actually decrypt this image and render visible the original.
It worked. You did it. Congratulations.
Yes.
Congratulations actually to everyone involved. That's amazing. Very impressive. For the audience, in the meantime, I think it's time to start posing your questions in the chat. So again, if you want to ask a question, you can just hover your mouse over the screen, and then a chat box will appear, and you can ask your question in this chat box, any question you want, and we'll be happy to answer most of your questions. What is important to say is that we'll finish the sessions at 2, but after 2, we'll have a networking session at the link bit.ly/quantumchat, and there we'll all be available to answer more of your questions, but also for a more dynamic conversation and those kind of things. So also make sure to join us there. But first, please start asking your questions. But first, Josh, you told me there's more.
There is, yeah, there's definitely more. So that first use of the key was really to take it slow and just kind of show how the whole process works, encryption, transmission, decryption, and such. We actually have 2 other applications that are connected to the system right now. The first one is with our partner Cisco. So we have the Cisco routers, again, putting the conventional internet traffic on the same fiber right beside our quantum signals. And those routers have special cards in them. They're called line cards. They're based on something called MACsec, a protocol suite called MACsec. And what they can do is if you give them key, they can encrypt every bit of traffic coming out of one router, basically going between the routers. And so they're configured right now that they're also accepting key from the QKD system and literally encrypting all the traffic that goes between the locations Delft and The Hague. Okay, so for time reasons, we're not going to look at this one, but it is working. The other one we're going to look at is a digital TV, a digital video streaming, encrypted streaming service. So as you and probably everyone watching knows, most TV, all TV nowadays is digital, right? It's streamed from some digital server somewhere. And in Europe, there are well-established algorithms to do this. These are standardized algorithms. Everyone is doing them. It's called CSA, the Common Scrambling Algorithm. And what we have set up is there's a digital video streaming server sitting in the KPN building in The Hague. It's going to request a key from the QKD system to encrypt the video that will then stream to the location in Delft. Delft will then also pick up a key and decrypt the video. So if everything works correctly, then the video should just start playing in Delft. I mean, as one would expect while watching a video streaming or digital TV.
Very impressive, very logical to do that right now. Very something we use every day, actually.
Yeah.
Let's have a look.
Yes, but actually we can go a step further. We can encrypt a video stream. So we'll send a request to Bob to start this encrypted video stream.
Now I've also started to respond to this request, and once I get my secret quantum key, I will start an encrypted video stream from Bob to Alice.
Yes. And here we have our encrypted video stream.
At QuTech, we don't just believe in the quantum future, we're creating it. We're developing prototypes of a quantum computer and a quantum internet.
The MDI-QKD protocol is future-proof.
And this is like a stepping stone towards a full-blown quantum internet that we are building on at QuTech.
Very impressive. Congratulations. It's very nice. Jesse, what does this achievement mean in the larger context?
So there are 3 topics that I would like to mention here, because this is a very good step in the developments that we would like to achieve within Quantum Delta and the connected institutes. This is a development within QuTech that we can stimulate and bring further, like we also do in other products and other entities in the Netherlands connected to Quantum Delta. The second one is this is the first element that we can build for building up a national quantum network. The aim that we have in the CAT2 program for Quantum Delta to build up between now and a couple of years from now a first national network that can be used as a stable network to deploy application on it or to develop applications on it for future use in the digital infrastructure. And the third one is the international perspective there. Later on, we have a good presentation of a quote from one of the international guests there, but he is driving the developments within the European Union to come to a European quantum network. And this is such an important development that we can use on national level, but also what we also can deliver on international level to deliver first connections with our neighboring countries from Germany to Belgium to France, etc. So an important development that we can use in many ways, and I think this is a first step, but much more will come.
Wow, so it's kind of a first step into an international quantum internet.
Correct. Yeah.
Very nice.
Yeah. Yeah.
And You actually already mentioned it a little bit, but we have some special guests, some special people who would like to emphasize the importance of this demonstration to you all. So let's have a look.
My name is Thomas Skordas, and I am the Acting Deputy Director General at the European Commission's DG Connect. Today's demonstration is a landmark for the development of quantum communications in Europe. The MDI-QKD system is a clear step towards actual implementation of quantum key distribution technologies in real-life scenarios. And the recent cyber security incidents that we all experience show exactly the need for developing these kinds of technologies. At the Commission, we are working with you and your country and another 25 EU member states and the European Space Agency to build a pan-European quantum communication infrastructure over the coming years using terrestrial and space technologies for quantum key distribution across Europe. I very much hope that your team will contribute your expertise and innovation to this major initiative, and I wish you every success in doing this.
Congratulations QuTech with its first major milestone in quantum networking. I'm Hein Dekkers from Cisco Netherlands, and we are proud to be part of this great innovation. And we are looking forward to working with QuTech in the future.
Hello, my name is Slootmaker and I am the Chief Information Security Officer of KPN. Today, in collaboration with QuTech and Cisco, we celebrate the achievement of a major milestone in the establishment of a quantum link using a commercial KPN fibre. This is the first step towards future-proof security for online banking and for the critical communication. And also for KPN and Cisco, this is an important milestone because it aligns with our early identification of major technological developments and their impact on risks and opportunities. I would like to congratulate the entire team who has been working on it, look forward to working with them in the future, and wish you all a very nice demonstration today.
Hello, my name is Groeneveld. I'm the president of AFCIA chapter The Hague, and I would like to congratulate you on this milestone in quantum key distribution. In the military, quantum technology seems still far away, but if it's there, it will change the security landscape significantly. Starting with quantum key distribution, and then decryption will be very important. And on the horizon, possible application in sensor technology or communications will be game-changing. Just highlighting the significance that the Netherlands is front and center in these developments. Thank you for the good work.
Kees Eijkel just joined the table. Kees is Director of Business Development at QuTech. Thank you for being here. Very warm welcome to you as well. And Kees, what are the real opportunities at hand now with this cryptography system?
Yeah, well, as you know, we all want safer internet. We want safer connections, and quantum is coming to help us with quantum key distribution. And today we show proof of concept, the first time globally, I think, that MDI-QKD is shown and it's becoming available. We can do use cases on it. And it's great that together with Josh's team and KPN and Cisco, we've been able to make this work for the world now. And the next step is to bring it to Quantum Delta, to our national program, and make it available to users. And that's when users can start playing around with their use cases and create value. And there's a lot of value to be gained with more secure connections. And at the same time, it's really important for us, we're technologists, we're already happy today because we can show that our stuff works. But now we want users to come back to us and say, hey, when you make your next version, this is what it's supposed to do. This is where we want to go. And so for us, the connection to the users is essential in creating success out of this technology.
I see. Thank you. And what does this mean for the local ecosystem?
Yeah, for the local ecosystem, the Netherlands, our own Delft environment, I think it's crucial. I talked about our users. The Netherlands needs to embrace these technologies soon. The users have to come to to play with the technologies and learn about them. At the same time, this is a Dutch technology. We have the patents, the knowledge, the know-how secured in this country. And so that allows us to further build the supply chain that is needed to create these systems and services on top of them. And we're working hard to make that happen. So the commercialization also is something that is in our hands. And together with the partners in Quantum Delta, we're going to make that a success. At least we're set to do so. Thank you.
Thank you. No doubt you will, actually. Thank you. Let's go to Victoria. Victoria, can you provide some additional context as to what this work, this demonstration means for telecommunication and for KPN specifically, and who are the first customers that have access to this?
Right. So we have to realize that QKD, quantum key distribution in general, offers a very strong kind of security. And therefore, the customers that could benefit from this kind of security are those for whom the security is crucially important. Now, the examples of parties who could benefit from this really strongly would be all the critical infrastructure. So we have military, we have government, we have the police, but also health records, right? This is data that has a really long lifespan and therefore has to be very strongly protected for a very long time. Yeah. Maybe more on the commercial side, we can talk about banking. So for example, communication between different banking units, or data centers and communication between them. Another point that I would like to stress here is that QKD, MDI-QKD, is not a solution that should exist on its own. It should be embedded in the system that really protects holistically, right? So we, for example, have quantum key distribution, and then in synergy with other protocols, really creates this idea of security as an onion, right? If we peel it, there is still something left at the core. And that's a very important point here.
I see. So it will be the future security, but it won't stand alone.
Hopefully, yes.
Thank you. And Josh, how do you see your accomplishments and what's next?
Yeah, I'm really proud of what the whole team accomplished here. When we pulled the trigger on this, when we said, okay, let's do it, of course, we built everything in Delft and we tested it extensively in a wide variety of parameter settings and such. But we pulled the plug on it on Monday morning, disconnected everything. At lunch, we loaded it on the truck, as we saw in the earlier video. And before the end of the week, it was running again between the 3 cities. And I'm super impressed and proud with how quickly we managed to just deploy it and get it working again. And we can do that again. I don't think there's anything stopping us from unplugging it, moving it, and going again. As for what's next, that's what you asked, there's a couple things. I think one thing that we can really do at this stage is scale out the network to more users. Because of the one central node, we can put, again, the boxes look very similar to this in the end. We can put these at one location, and it's a single fiber to the center node, and then these users are just connected to the rest of the network, and they can distribute key where they want. So this is one thing, scaling out the network. And the other thing, so we showed integration with some of the KPN, one of their systems, and also their standard fiber, their locations, and also with our partner Cisco, right? Integrating with their conventional internet traffic systems, their conventional routers and such, on the same fiber side by side. And integration is kind of the next step. So the question is exactly as Kees was saying a second ago, it's who are the users that want to connect to these key servers? What applications do they have where they feel they could benefit from something like quantum key distributed key? Integration is the name of the game, I think.
Sounds good. And which city is next?
Yeah. If I had to guess, maybe Zoetermeer, where we are right now, actually.
Of course.
It could be.
And we can all broadcast our stream
to
everyone via secure quantum key. That would be impressive. Okay, I think it's time to have some questions from the audience. So please still feel free to ask questions. You can do that by hovering your mouse over the screen and a chat box will appear. And we're happy to answer your questions. And let's see, Marie-Christine, do you have some questions in already?
Yes, we have some first questions in already. And the first one is, Joshua has mentioned the Cisco routers. And can you be more specific on what they're actually doing in the QKD system?
Perfect. Well, I think, Josh, this is a question for you.
Yeah, sure. Yeah, definitely. So to be clear, they're not in the QKD system, right? I mean, we're running in parallel, which is really the key thing here. What we're showing is that our hardware, the QuTech quantum hardware, runs alongside Cisco hardware. We show that the Cisco hardware runs alongside quantum hardware. The two are running in parallel. They coexist. They work together work together well. Yeah. The Cisco hardware, I think my colleague Raymond talked about it. It's generating two, in very technical words, they're called WDM networks over there. Both of them are inside what's called the C-band. They're being deployed over the fiber. There's different optical configurations, and creating the two different networks in the end. So it's really an air-gapped network that we have deployed out there, just so that we connect to it.
Interesting. And just out of curiosity, these networks do not interfere?
That's right, exactly. They don't interfere, and that's really the key thing. So using some specific WDM technology, we're able to make sure that the networks don't. The quantum network and the classical network don't interfere with each other.
Nice, thank you.
Yeah.
We have more questions.
Yes, there's actually quite a few coming in. The next one is, if the Charlie node is trusted to perform the Bell state measurement, what if this center node is compromised, and what happens to the security of the system?
It sounds like a question for Josh again.
Yeah, okay. No problem. Yeah, it's a really good question. And this is intrinsic to the MDI-QKD protocol in and of itself. So if the center node does any measurement other than that Bell state measurement, it shows up into the end nodes in the exact same way as if an eavesdropper was tapping the line trying to learn the secrets. So again, the center node doing anything other than a Bell state measurement will immediately raise alarms in the end nodes. And then they know not to trust that center node.
Exactly. And the measurement is discarded.
These measurements are discarded, that's right. Yep.
Thank you.
Yeah, as the next question, we have someone wondering about the next steps. Are you planning to use existing telecom fibers to extend your network? And what would be the challenges there? And maybe I'll add the connected question. Are you actually planning to keep using standard telecom fibers, or is there something different you have in mind?
Victoria, I think you can say something about
this. Yes, I would love to say something about this. It would be great to continue using the standard telecom fiber, and the reason for this is actually very simple. This is one of the motivations for why we want to consider MDI-QKD alongside of regular internet traffic. And therefore, if, like we saw, this is possible. Yeah. And that means that we can use existing fiber infrastructure that's already in the ground and that's covering not only Netherlands but also Europe very, very densely to extend the network onto other cities, other countries, and preferably have a inter-city and inter-border connection.
Of course, yeah. It's very, very smart to actually use a network that's already there, right? Yeah. It's already provided. Thank you. Do you have more questions?
Indeed, I have. The next one is, how do conventional or future encryption algorithms interface with this QKD? Does that work, or do you need specialized algorithms?
Josh, do you need specialized algorithms?
No, you don't need specialized algorithms. That's true. The key servers are there, running on the end nodes, solely for the purpose of taking the QKD key, holding it, and then handing it out to whatever applications or algorithms want it. It's a standardized interface. We're actually using an interface that's defined and standardized by ETSI already. So I mean, anyone can program against this interface to request key and accept key and then use that key. There's nothing new should new algorithms get developed.
Let's see. Thank you.
Can I maybe add to that something? So like Josh said, the MDI-QKD produces a key that's the same on both sides. That's called a symmetric key because it's exactly the same on both sides. And any application that actually takes in symmetric keys and uses encryption on top of that can use these sort of keys. Now, one example of that is post-quantum cryptographic applications, which, like I said, would be working in synergy with QKD, giving a really, really strong kind of protection to any kind of security, any kind of communication that is securely being carried out on the fiber.
That makes sense. Thanks. Very impressive. Marie-Christine, are there more questions?
Indeed, there are. I have a next one asking, what kind of network structure do you envision for MDI-QKD? Is there going to be some general backbone, or is it point-to-point?
So I think, Jesse, do you want to say something about that?
The most details, of course, have Joshua, but I think it's important to reflect on the infrastructure that we have today, as Victoria also said, and how can you support the existing infrastructure and build up the connections there. And it's could start with point-to-point, but also with the central node as presented here, you can connect many locations in a star network and drive further from there to the existing infrastructure that we have today.
Yeah.
Maybe you can add things where necessary.
Yeah, no, it's exactly the case. I mean, and starting with a single center node and building your star out makes total sense. But then when you have a couple different stars, it also makes sense to connect these stars together, presumably by the central nodes, in particular because these center nodes can operate in the future with things like quantum signal repeaters and such. Yes. That's also a way to get trust end-to-end from different stars, for instance.
So you have different stars connected together, and together they're the whole network. Mm-hmm. Makes sense. Thank you. Marie-Christine.
Actually, quite a few people have asked this. Currently, the wait time you had is 4 minutes. Do you think you can get this down in the future? And are there challenges connected to this?
Ooh. Josh, can you get this down?
Yeah, sure. So, okay, no, that's a good question. Maybe that's mildly misleading. So the system, the way QKD works is when you first turn it on, it takes a little while to generate key, but you get a lot of key at the end of that 4 minutes. So I think as Thomas said in the video, we get one AES key on average every 30 seconds. So although we waited 4 minutes, there's many keys that are there. And so it's effectively, again, once you boot it up, you wait some period of time, then you get a lot of keys. Then you wait this period of time again, and you get a lot of keys again. This is normal. And as long as you're not using more keys than you make in a period of time, then you should be okay. The key servers are there to essentially collect up these keys and make sure there's enough of them to hand out to applications, make sure there's enough keys available for everyone that wants them.
Yes.
Exactly, yeah. In parallel to this, I'll just say, we also have plans to increase the speed of the system over time, but yeah.
It will take time.
I leave it at this, yeah.
Of course, of course. Marie-Christine, do you have more questions?
Yeah, there's a very applied question, let's say. Someone is wondering if an application on my computer now needs a quantum key. Do I need a specialized box? Or do I get it from a quantum box far away? How do you connect to this?
How do you connect to this? Maybe Victoria, you can say something?
Yeah, I can say something about that. Right now, we indeed need quantum boxes. And actually, in order to connect to whoever, with quantum communication, you necessarily need a quantum box. Yeah. Now, there are different ways to route this key traffic over the network. And this is something also that's being explored a lot of times, I mean, by a lot of people all over the world, how to handle these keys if a single user requests it. But indeed, to achieve the strongest kind of security and to have a quantum protected link, we necessarily need a quantum device. Nice. Hopefully, in the future, they will get a little smaller, a little cheaper, and everybody will be able to just plug it into their computer.
I see. Thank you. And Kees, how do you envision this? Does the whole world have such a quantum box in the end?
Well, part of this has to be found out over time. I mean, you're talking about how we distribute the keys and which parts of the keys are going to be quantum and stuff like that. So there's lots of solutions to raise the security of the network with quantum. At the end of the day, if you want pure security of your connection, then you need a specialized box at your place. And trust yourself as a trusted node there. And on top of that, I think the developments now, this is proof of concept, first time to the world. And we're going to see a lot of miniaturization and standardization and ramping up in these areas. So it's still hard to see what the future holds in that, but looking at the very many things we've seen in the past, today even your watch as a video screen, I mean, just wait and see how technology brings us further. And we're working hard on that, yeah.
I'm very excited for that, actually. Marie-Christine, I think there's time for 2 more questions. Is that correct? Yeah.
Then let me start with this one. What is the difference with MDI-QKD to other QKD protocols out there? And yeah, what are the advantages or drawbacks compared with those existing protocols?
Yeah. Well, maybe from a commercial, Josh, you and I can
sure, yeah.
share this. But first of all, I mean, star-shaped is way more scalable than what is out there today. The traditional QKD systems are point-to-point, and that is very, very limiting. So with that, I think we have a trump card, as they call it, in our hands to play. Another one is that it's intrinsically safer in a number of regards. And then thirdly, of course, and I think Josh has to now kick in also, it is future-proof, because the technology we build today also is able to develop towards the future. But maybe you can say a little bit more about that.
Yeah, exactly. I mean, so there's also the question about drawbacks. So maybe I just say this first to get this out of the way. The center node it's a bit of an upfront cost, right? You have to build this once, but once you have this, then you can just start adding users around the center node, right? And then the other thing is that, as Kees was talking about, this future-proof, the center node, it's the same center node that are being used for things like connecting quantum computers, for things like connecting quantum repeaters, teleportation, quantum teleportation. There's so many other applications that rely on the same physics measurement that goes on at that center node, the Bell state measurement. So you can set up one of these, and then you're good into the future, which is important. I think we all feel for many operators, people that want to build.
But that sounds good, actually.
We like to think so. Yeah.
I think last question from the audience.
Then let me choose this one, because quite a few people have asked this one. Is there a distance limit at the moment for QKD, for this specific QKD? And will this change in, let's say, 1, 2, or 10 years?
Nice. I think, Jesse, let's start with you, and then Josh or Victoria.
I think Joshua can speak more about the distance, but of course, as we've shown here, we have limitations. Yes. But as I shared also in answering a couple of these questions, we have the plan to build out the national network. Yeah. So the developments around the distance, maybe with repeaters or with changing the lasers or the attenuation, that will be important to deploy these networks on national level and on international level.
Thank you.
Maybe you can tell something about the developments for this.
Yeah, sure. Exactly this. So, I mean, there is a limitation of distance. We lose those quantum signals after some period of time. But as Jesse said, we have plans to change some of the lasers, change how the qubits are made to make them, let's say, more robust against more loss or so, something like this. But on top of that, there's also many develops going on, not just in the Netherlands, I mean, all over the world, in these things called quantum repeaters. Yeah. Once we have these, then we have the capabilities to really move these quantum signals unlimited distance in the end, is what it comes down to. But that will take time. The question said 2, 5, or 10 years, and that's likely the longer side of that timescale.
I see.
Yeah.
Maybe it's good to give some ballpark numbers where we are now. What distances can we cover today?
So with these, right now, we can get up to about 150 kilometers in total. This is good. We're shooting for getting close to 250 after we make a couple upgrades over the summer. Yeah.
So you can almost cover the whole of the Netherlands already. Correct. Good to be a small country, I guess.
Exactly. I'm very glad to be in the Netherlands.
And Victoria, is KPN ready? Is the network of KPN ready for these quantum repeaters and everything?
For quantum repeaters, that's a question of further ahead in the future, of course. But like Josh said, it's important already to start implementing these central nodes associated with MDI-QKD, such that later on in the future we can upgrade them into something that is able to carry out real quantum links.
Yeah. Thank you. I have one more question myself, actually, because the Netherlands, or the government of the Netherlands, recently announced a lot of commitment into quantum and quantum computing and quantum communications specifically. So how does your work connect to future projects in this whole commitment? Maybe start with Josh and then Jesse. And then
yeah, sure. I'll just say quickly. So we've started working with KPN and some fiber and some infrastructure locations. Within the next, I won't say a timeline on this, but in the future, we're going to be upgrading those end nodes actually to some new systems that involve some quantum memory and quantum processing capabilities. That's going to be upgrading the end nodes, but using the infrastructure at the center node. And that's part of this development that's going forward, for instance.
Thanks. And yes, would you like to add something?
Yeah. And of course, by the commitment from the national government, by the Groeifonds, the Grow Fund, to stimulate innovation in the Netherlands is a very success story for the quantum industry in the Netherlands. With that commitment, we can drive many new technologies in the Netherlands, drive it from where we are now and speed it up into the future. And this is a great example what has come out from these developments. And we need to adapt this further also in the program and to drive this further to the next level. It's important for the national developments in the Netherlands, but also important for the international collaboration, because that's crucial to build up internet networks. As we all know, the internet is containing thousands of networks, and only by collaboration we have the internet as we have it today, and that's also what we need to translate to quantum computers and quantum networking.
Sounds good. And this was the first step. Would you like to add something, Victoria or Kees?
I'd like to, sort of call to action. I mean, start using this stuff. Engage with us, create use cases. Also, like playing around with this stuff, because the investment of playing around with these networks and creating use cases today is going to help you be ready for the future when this stuff really kicks in. And that will be a few years from now, but not too long. So engage with us at Quantum Delta and QuTech.
I think a very important call.
Yes, if I may add to that, absolutely. Call for action, that's a definitive next step. We need more customers who think they might be able to benefit from this technology. And even if you think you can do it, just reach out to us and we'll make sure that we have a good conversation about this. Identifying these use cases at this step is extremely important, and we would really like to engage with people who might have some ideas.
I think that's a nice point to conclude. Right. Everyone engage. And this concludes this live studio event. But before we go, I'd like to emphasize and remind you again that we will continue again online in a networking event happening, well, in a couple of minutes, I would say, on Wonder, which is a very easy to use tool that will allow us to create a more interactive and more dynamic conversation. And in this tool, you will find 3 bubbles. The first bubble focuses more on the technical aspects of this demonstration and will be hosted by Thomas and Raymond. You just saw them in the movies, in the demonstration. The second bubble will focus more on applications and will be hosted by Victoria and Ingrid. You saw also Ingrid in one of the movies or in a couple of the movies. And the third bubble will evolve more around future plans and will be hosted by Jesse, Kees and Josh. And with that, and on behalf of QuTech, Quantum Delta NL, KPN and Cisco, I would like to thank you all for joining this event, and I hope to see you all shortly on this Wonder, which is at bit.ly/quantumchat. Thank you.